voltage. Today we will discuss the Thevenin equivalent circuit. The theorem states that any two-terminal bilateral electrical circuit can be transformed into a Thevenin equivalent circuit, which will consist of a source, voltage source, that will be called Thevenin voltage source, and a resistance, which will be called Thevenin resistance. So we can think of a network which consists of resistances, okay, resistor network, with voltage source, terminal A and B. So this can be transformed into an equivalent voltage source. We can call that voltage source as VTH, and RTH, which is called Thevenin resistance. Okay, so the procedure which we have to follow in order to transform this resistor network into this shape is that we have to first, as a first step, we have to remove the portion of the circuit across which we are interested to find out the Thevenin voltage and Thevenin resistance, in which we are interested to transform into the Thevenin circuit. So that portion of the circuit has to be removed. Okay. So as a first step, we have to remove that, and as step number 2, we have to find out the voltage VTH across the terminals AB. So what we have to do, we have to find out that voltage by using any technique. For example, the node voltage method. So we have to use the node voltage method to find out this voltage VTH, which is basically VAB here. Okay. Then, as in step number 3, we have to make all the voltage sources short circuit and all the current sources open circuit, and we have to compute the equivalent resistance, and that resistance would be serving as Thevenin resistance for that. So this is one way to compute the Thevenin resistance. The other way to compute the Thevenin resistance is that we have to make the two terminals AB as short circuit, and we have to find out the short circuit current in the circuit then. And after finding out the short circuit current, the Thevenin resistance will be equal to the VTH divided by ISH. So in this way, we have to find out the Thevenin resistance and the Thevenin voltage. So I summarize these steps again. As a step 1, remove the load side of the circuit from the circuit and compute the Thevenin equivalent circuit for the remaining portion of the circuit. So how to compute that? As a first step, we have to compute VTH, and VTH can be computed by the node voltage method, for example. Okay. As a second step, make all the voltage sources in the circuit short circuit, make all the current sources in the circuit open circuit, and then compute the equivalent resistance. And that equivalent resistance would be serving as Thevenin resistance. This step can be alternatively divided into 2 further steps if you want to have some other, if you want to use some other technique or some alternative technique. So in that alternative technique, make the terminal AB short circuit, leave the current sources, voltage sources as it is, and find out the short circuit current. Once you find out that short circuit current, VTH is already with you, so compute the Thevenin resistance by using the equation that VTH divided by ISH. So this procedure we have to explain with some examples. So we will solve a couple of examples on it. Okay, so we have this very simple circuit resistor, and we want to compute the Thevenin equivalent voltage and Thevenin equivalent resistance for this circuit. So the first step is already done. We have removed the load side of this circuit, and the remaining circuit we want to transform into Thevenin equivalent circuit. And the Thevenin equivalent circuit is the equivalent Thevenin equivalent voltage and Thevenin resistance. So just to find out the Thevenin voltage, we use the node voltage method. We just label the essential nodes. So essential node 1 and 2. This 2 is considered to be as reference node. So writing the equation for this node 1, so we can write this as V1 minus 25 divided by 5 plus V1 divided by 20 minus 30 equal to 0. Okay, so this V1 will be equal to basically VAB, because this VAB is open circuit. Okay, so we can just to find out V1, we will definitely have the Thevenin voltage. So just rearranging this expression, we can write this as just the LCM of this is 20. So we can write this as 4 V1 minus 25 plus V1 minus 60, because 20 times 3 is 60, so equal to 0. So we have 4V1 and V1, so this is 5 V1, and this is minus 100 minus 60 equal to 0, which is equal to 5V1 is equal to 160, and V1 is equal to 160 divided by 5, which is equal to 32 volts. Okay, so we found out the Thevenin voltage, which is equal to 31, because V1 is equal to VAB. So we can simply write this as VAB, and which is equal to VTH. So this is 32 volt. Now we want to find out the Thevenin resistance. So in order to compute the Thevenin resistance, make this current source is open circuit, make this voltage source is short circuit. So just if you want to make it as short circuit, and you just open this circuit, so you will have something very interesting. 5 ohm in parallel with 20 ohm and in series with 4 ohm resistance. So you will have a circuit like this. I just want to redraw the equivalent circuit. This will be something like this: 5 ohm resistance, 20 ohm resistance, they are shorted, and you have 4 ohm resistance. Okay, so the terminal are, you can just see the equivalent resistance, and this equivalent resistance would be exactly like this. So 5 ohm in parallel with 20 ohm in series with 4 ohm resistance. So Thevenin resistance is equal to 4 ohm series resistance, so that's why we add this plus, and 5 ohm resistance, which is in parallel with 20 ohm resistance. So 4 ohm and 5 multiplied by 20 divided by 5 plus 20, which is 25, and this is 100. 100 divided by 25 is 4. So 4 plus 4 is equal to 8 ohm resistance. Okay? So we found out the Thevenin resistance. So this is the Thevenin equivalent circuit for this portion of the circuit. Okay, so if you want to use the alternative method, and the alternative method is that don't make it a short circuit. Okay, don't make it open circuit. Leave all the things as it is. Just make this terminal as short circuit. With the two terminals A, B, they are made as short circuit, so we have to find out the short circuit current. And once we found out the short circuit current, the voltage divided by that short circuit current would be equal to the Thevenin resistance. So let's see how we can use this. So making these two terminal short circuits, so we are using the alternative method. Okay, again apply the node voltage method. So let's assume that at this stage we have the node 1, 1. Okay, you can name it, you can label it another name if you just not happy with 1, 1. So it's up to you. So we just make it node number 1, 1, and this is reference node. So applying the node voltage method to this circuit, we have V11 minus 25 divided by 5 plus V11 divided by 20 minus 3, and we have, if you just look at here, reference node, so V11 divided by 4. So plus V11 divided by 4 equal to 0. So this is the node voltage method, and we have to compute V11. So again, solving this solution is very simple. So it will lead us to V11 is equal to 16 volt. So the short circuit current is the current flowing through this resistance from terminal A to terminal B. So from this node V22 to terminal B. So this is the short circuit current. So ISH is equal to V11 divided by 4 ohm resistance. So V11 is 16, and this is 4 ohm resistance, so it is 4 ampere. Okay? So now, we know VTH 32 volt, we know the short circuit current, so we can now find out the Thevenin resistance is equal to V11 divided by ISH, so this is 32 divided by 4 is equal to 8. So you see, we have this Thevenin resistance. So with this, you can see it that we can use either method to find out the Thevenin equivalent voltage and the Thevenin resistance for the circuit. So we will see some more examples to show how this method is useful and how this method can be used to find out the Thevenin resistance